All right, guys, part 2 of your digestive system we're going to start today. Great job with your comments. Thanks for watching the video. We'll just keep this rocking and rolling throughout this semester. If you have any questions at all, don't hesitate to ask. Just let's have some fun with the questions. You know, don't say you don't have any questions. It doesn't even have to be about digestive system. You guys like getting me off topic. Let's have some fun. Let's be silly with it if you want to, within reason. And throw them out some questions, and I'll be glad to answer them at the beginning of each video. So I got a handful of questions to answer here. Emily asked about diverticulitis. Diverticulitis is a pathology that we're going to talk about near the end of, if we have time, I might come back and hit it. But diverticulitis is an infection, well, not infection, inflammation-itis that comes from diverticulosis. Diverticula are just little outcroppings in your small or large intestine. And so what diverticula create are just little blind passageways where stuff goes in, but it doesn't come out. And anytime you have stuff that sits like that, especially with all of the bacteria that are in your digestive system, you could get an infection. You could get bacteria that just overtake it, and then that's where you get the inflammation, and that's where you get the pain and the stomach issues that come along with diverticulitis. One of the things that they tell you not to eat certain small little undigestible things like peanuts, because they can get stuck in those diverticula and start to gain bacteria and almost become gangrenous, and you can get some pretty nasty infections, and that's where the diverticulitis comes from. And so you try to change your diet up a little bit, and in extreme cases you could actually have to have procedures done to repair inflamed diverticula. Damien asked about how much hydrochloric acid is in the stomach. This is a really complicated question to answer. It really depends on who you are. It depends on what you just ate. If you haven't eaten in a while, you don't have much hydrochloric acid in your stomach at all. If you eat something that it takes a lot to break it down, something that has a lot of oils and fats and complicated carbohydrates, more acid is going to be released. And then some people just make more acid than others. Most of your anti-heartburn medication, things like Prilosec and Pepcid, ranitidine, those things are going to just tell your body to release less hydrochloric acid. And so that prevents the esophageal reflux with heartburn. Kaylin asked, what would happen if you didn't have gastric juice? Okay, so if you didn't have gastric juice, you pretty much wouldn't get any chemical digestion, which means other than what you do chewing up your food physically in your mouth, you wouldn't get any more digestion going to food to your small intestine. If you didn't chew up enough and things got to your stomach that couldn't pass through the pyloric sphincter, which is the end of the stomach going to the small intestine, then you would regurgitate it. You would have probably had lots of upset stomach issues, vomiting, and then the things that actually do get to your small intestine would not be as digestible, so you could end up with some malnutrition. You would have probably some pretty nasty stools, and be a pretty unhealthy individual if you just plain didn't have a stomach. You could didn't have gastric juice. You probably could get away with not having gastric juice if you completely change your diet to a liquid, nutrient-rich diet, but it wouldn't be a very fun lifestyle. Like I said, I know I didn't start the questions until the second day, so come and hit me with more of those questions, and we'll have some fun at the beginning of each little video. So let's go ahead and finish up digestive system. We stopped with stomach. Let's head on to the small intestine. So the small intestine is going to be where the actual work of your digestive system happens. This is how you get your nutrients into your body. And a bunch of people answered the question about why do we need nutrients to get energy for the body. Excellent. You also need building blocks to build stuff. You know, everything you are is what you've eaten. And that's pretty wild if you think about it, because what you do with your nutrients is you break apart the chemicals and then you put the chemicals back together as proteins and lipids that fill up your body. So the atoms that make you up are atoms that you've eaten. It's a pretty wild little deal. The beginning of the small intestine is your duodenum. So the small intestine is actually 3 parts. It's going to be the duodenum, into the jejunum, into the ileum. And really only 2 of those we're going to spend much time on. Jejunum is kind of just a connection, but we'll start off with the duodenum. Duodenum is the little curve that of your intestine that comes out of the top of your stomach. It's in the right upper quadrant of your abdomen. If you remember, there's also some other very important things that are at that junction. Hopefully we do get to dissect our cats and we'll find the duodenum. The duodenum is a super important spot for anatomy because everything kind of comes together. So you have this digested product that's coming out of your stomach that has been bombarded with this acid. One of the first things you got to do is get rid of this acid, because if you let the acid keep on rolling down, you're just going to be absorbing acid to your body, and that's not healthy. So we have to neutralize that acid. And one of the main ways we do that is we put bile into the duodenum. It's going to receive bile. We'll talk about bile in just a second. It also receives pancreatic juice. Pancreatic juice is collective name for just fluid that comes from the pancreas that's going to help to neutralize the acid, but also help to regulate your sugars in your body, like with your insulin and things like that. And then the main job for this stuff is to buffer low pH. So like I said, duodenum, right upper quadrant of your abdomen, your liver's there, your gallbladder's there, your pancreas is there. Everything is all connected there at a super, super important spot for visual anatomy. And like I said, I can't wait to show it to you in the cats. Next up, I didn't really say, not much to say about the jejunum. The jejunum just continues down from the duodenum and connects to the ileum. The ileum is the major part of your small intestine. So when someone says intestines or when someone says small intestines, most of the time what they're talking about is ileum. This is where most of your nutrient absorption occurs. Most of your nutrient absorption occurs in your ileum, and this is what you see. Like if you're watching a scary movie or something and somebody gets gored in their stomach and they're standing there holding their guts, you're seeing ileum. That smooth, tubular looking long stuff coming out of the intestines, coming out of the abdomen, that's ileum. Ileum pretty much fills up the majority of your abdominal space. It can be very, very long because it's all about getting surface area. And now it's long, so you have a lot of surface area to absorb nutrients, but also it is wavy on the inside. And so you have these villi. V-I-L-L-I, that are going to be just kind of waves. So if you cut the ileum in half, you would get these villi are just these outcroppings in your small intestine. But then on the villi, you have microscopic outcroppings that keep on waving called microvilli. These microscopic little outcroppings. If you zoom in, it does this exact same little wavy motion again, but on the surface of the villi. And so it's all about getting the most surface area possible to absorb as many nutrients as possible. This is all about increasing surface area. Now, we're going to take a little bit of a side here and talk about some non-alimentary canal organs. There's a couple of organs here that are accessory organs for your digestive system that have to do with directly your small intestine. I mentioned them a little bit, so let's go ahead and talk about the liver and the pancreas. The liver is going to produce bile, amongst many other things, but for the digestive system, the liver's job is to produce bile. It's going to be stored and released by the gallbladder. It's going to be stored and released by the gallbladder, and bile is a fat emulsifier. Now, take you back to chemistry just a little bit to remember what emulsifying is. So, remember we talked about polarity of water. Water can dissolve lots of different things because water has a positive end and a negative end. So water is really good at dissolving salt because sodium is positive, chlorine is negative. Sodium, the positive thing, is going to be attracted to the negative oxygen in water. Chlorine, the negative thing, is going to be attracted to the positive hydrogen in water. Now, this is great as long as the thing has a positive and negative end, as long as the thing is polar. But if you try to put oil in water, nothing happens because oil doesn't have a positive and negative. Oil is just this non-polar mass where one end is not different than the other. So when you eat oily things, when you eat fat, your body tries to hit it with water and nothing happens. You just get this blob of fat that's just extra around the water and acid that you're trying to do. So what happens is bile from the liver is going to emulsify it. Bile has one end that is polar, positive and negative, and it can grab a hold of water, and one end that is non-polar, it can grab a hold of oil. So you end up grabbing and dissolving what you're not able to dissolve. Now, when you have like gallstones or when you have things that you're not releasing enough bile, you end up with these greasy, fatty stools and with stomach problems and with malnutrition because you're not able to emulsify that fat. So the fat emulsifier is going to allow fats and oils to dissolve. I'm going to skip the pancreas. I changed my mind. Pancreas got lots of enzymes to help digestion finish. I'm reaching the point here. I want to go ahead and try to finish up. So I'm going to go ahead and roll to try to finish up these notes today. We're going to go ahead and go to the large intestine. So the large intestine is going to begin at your right lower quadrant of your abdomen, and that area is called the cecum. At the cecum is where your appendix is. So when you have someone that has, we talked about it before, that rebound pain in their right lower quadrant, that you should worry about appendix, because appendix is a blind pouch, kind of like those diverticula we were talking about earlier. So the cecum is going to begin your large intestine, and your large intestine is going to go up in your abdomen, and this is called the ascending colon. All All right, it's gonna go up. The ascending colon goes up in your abdomen, then it's going to take a hard right turn at your liver. That's called the hepatic flexure. Hepatic for liver, flexure for being a bend. And then your colon's going to go across your abdomen. This is called the transverse colon. After you go across the abdomen, takes another hard right turn. This is called the splenic flexure. Splenic for spleen, flexure for turn, and you're going to go down the descending colon. Now, if you go straight down from there, you got a problem because your rectum is central and the end of your colon is over here. So now in a cat, you would just descend down straight to the rectum because everything's straight and narrow. In a human, though, the colon has to take a curve and come to the center, and this is called the sigmoid colon. So the sigmoid colon just curves the colon back over to the middle of your body, and then you're going to end up with the rectum, which we'll talk about next. The large intestine, which is all of these things, has one job only: get the water back. The large intestine is going to reabsorb water. So throughout your whole process, from the time you put food in your mouth to the time you were finished absorbing it in your small intestine, you've been shooting water at it. Your body has been shooting water at this food, and so you got to get that water back because we have to maintain homeostasis. So we got to reabsorb that water, and we just use that water over and over again to digest things. If you don't, you end up dehydrating very, very quickly. This is what happens with cholera. Cholera comes in, turns off this large intestine, and you end up not being able to drink enough water to catch up, and you dehydrate yourself, and there's nothing you can do about it. Large intestine reabsorbs water, and that's why you end up with nice, fully formed stools that don't have as much water in them. If you have diarrhea, probably something's going on wrong. You have some type of sickness, or you ate something your body's trying to get rid of. But the large intestine's job is to reabsorb water. And then finally, we end up at the rectum. The rectum's job is to store feces until time for release. Pretty straightforward. You don't want to just poop any old where. Birds do not have a rectum. Birds, as soon as they make their feces, it releases because they have to cut weight. This is why a bird just poops wherever. Whereas most mammals, reptiles, things like that do have a rectum because you don't want to poop where you eat or sleep. And so you go somewhere else, get that poop away because it usually has some digestive bacteria that you just don't want to be around your food or where you're sleeping. At the bottom of your rectum is your anal sphincter. The anal sphincter is just the muscular closure around your anus. It has both voluntary and involuntary mechanisms. So the top of the anal sphincter is going to be smooth muscle. And so you're going to end up with the urge to go to the bathroom, the urge to defecate. And then the bottom of the anal sphincter is going to be skeletal muscles, where you relax that skeletal muscle and allow your body to release the feces. One of the cool things about the anal sphincter is that it can tell whether or not it's holding back air, liquid, or solid. This is why you, most of the time, make a pretty good decision about whether or not it is a fart or something else. Every once in a while it makes a mistake, but most of the time we're pretty good at that. And that's a pretty wild little anal sphincter. There's sensory things there with that. So that's the digestive system. I have some other things that I can mention on that. We might do a third video on it depending on the questions, and we'll see where we go from there. But that's my plan, is to release videos on Mondays and Thursdays. If you have any questions at all, I'll be glad to help you out with it. Ask some fun questions. Let's have some fun talk, and we'll do pretty good heading on. Thank you guys so much for paying close attention, and I miss seeing you, and hopefully we're back to dissect cats. If we don't come back to school, I will do a video dissecting cats, and we'll see about maybe getting 1 or 2 people at a time to come and be in a video. I don't know, don't quote me on that. But we'll see. Hopefully we're back May 15th and we have a couple weeks to dissect cats. Miss you guys, bye-bye.